In this video, we are going to talk about the decimal number system, which is part of our base 10 number system, and sometimes it is referred to as a decimal system, even if we're only working with whole numbers. But let's get started looking at a place value chart for the base 10 decimal number system. Okay, so here is a place value chart. You can see the decimal point here in the middle, and to the left of the decimal point we have our whole numbers, which are place values ones, tens, hundreds. So just to review with our whole number place values, we are going to look at how we get each of those place value names and values, because I want you to see that the pattern continues even when we're working with decimal numbers. So to get our ones place, we get the ones place by doing 10 to the 0 power. Our tens place is based on 10 to the first power, and our hundreds place is based on 10 to the second power. And so if we were to think about this pattern and how it continues, if we keep moving to the left, we are going up 1 for each of these powers of 10. So that's moving to the left. If we move to the right, these powers of 10 are going to get smaller. So we go from 10 to the power of 2, 10 to the power of 1, 10 to the power of 0. And if we were to keep moving left, that pattern will continue, so that the place value to the right of the ones place is 10 to the negative 1 power. And then we have 10 to the negative 2 power and 10 to the negative 3 power. And so what happens when we have 10 to the negative 1 power? This mathematically is equivalent to 1 over 10 to the first power, which is equivalent to 1 over 10, because 10 to the first power is 10, and therefore 10 to the negative first power is 1/10. This is the same for 10 to the negative 2 power. It is equivalent to 1 over 10 to the second power, which is equal to 1 over 10 squared, which is 100. Or 10 to the negative 2 power is 1/100th. This is mathematically how we get our decimal number place values. So that 10 to the negative 1, or the first place value to the right of the decimal, is the tenths place. 10 to the negative 2 is the hundredths place. And then 10 to the negative 3 follows the same pattern, and the name of this place value is the thousandths place. So this is how we get the names of our place values. They are based on the values of the powers of 10. 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, and that goes on forever to the right. Just like our place values to the left of the decimal point go on forever to the left. They follow this same pattern, moving to the right or moving to the left. So let's talk a little bit about those patterns. As we've discussed with whole numbers, when we move from the ones to the tens place, we're multiplying by 10. This is true with our decimal place values as well, okay? The tenths, if we have 10 tenths, we get 1 whole. So when we multiply 1/10 times 10, it gives us 1 whole. Same thing from the hundredths place to the tenths place, and the thousandths place to the hundredths place. It is 10 times larger as we're moving to the left. Just like as we move to the right, we are dividing by 10. So as we move to the right, we're dividing by 10. As we move to the left, we're multiplying by 10. And it's really important that we see how that pattern stays the same even when we start working with decimals. All right, let's move on to how we say decimal numbers mathematically, and this will help us read and write decimal numbers as well. Okay, so we have our place value chart, and what I'm going to do is just put in one number at a time, and we're going to talk about how we say each example of these numbers. Okay, so first we have this number, which some of us might say as 2.3 or 2.3. And this is correct, but as we're teaching children, we want to make sure that if we say this number mathematically, it will make it easier for them to read decimals on a test, because the state will try to trick students, and we'll talk about that. So in order to read this number mathematically, I am going to say 2 and 3/10. Okay, at my decimal point is where I'm going to say the word and. This is separating my whole numbers on the left of the decimal point with my parts of wholes to the right of the decimal point. And so when we use the word and when reading numbers, it should only be said at the decimal point. So once again, to read this number mathematically, I would say 2 and 3/10. Okay, so now I have a 4 in the hundreds place, a 3 in the tens place, a 2 in the ones place, and a 3 in the tenths place. In order to say this number mathematically, I would say 432 and 3/10. Notice that I did not say and at any other part in reading this number. Sometimes we are used to using the word and in other parts of numbers, just in our everyday lives. I often hear or say 432. But mathematically, this isn't correct. Mathematically, we only use the word and to separate our parts from our wholes. And this is one way tests will try to trick students, because it sounds familiar. It sounds comfortable to say 432. Sometimes it's even quick, like 432, right? And so when we're teaching children, it can be easier for them to pick up on the mathematical way to read this word if we're saying it mathematically correct from the beginning. So even if we don't have decimal numbers in our content, we want to make sure that we don't use and where it's not supposed to be mathematically. Okay, let's look at some more numbers that move into our smaller decimal place values. So for example, this number, to read this number, I would say 2 and 3/100. Notice that I don't even need to worry about the 0 in the tenths place. I have no tenths. I only have 3/100. And so I don't need to say 0/10, 3/100. I can just say 2 and 3/100. All right, let's look at this number. I would read this number as 2 and 123 thousandths. Notice that I read all of this number as if it were a whole number, 123, and then I say the place value that it ends in, 123 thousandths. Two and 123 thousandths. Once again, I do not say the word and anywhere except for the decimal point. Even in the number 123 thousandths. This can be a hard transition to make, so I suggest you practice. Okay, let's move on to writing numbers, decimal numbers in expanded form and expanded notation. Okay, so this is an example of expanded form on the left and expanded notation on the right with whole numbers. So we're going to use this as a reference to think about how to use both of these different ways of writing decimal numbers. Let's use the following number as an example. To read this number, I would say 435 and 268 thousandths. To write this number using expanded form, I am going to separate each value out from its place values. For expanded notation, I'm going to do the same thing, except this time I'm going to make it a multiplication problem using my powers of 10. So same thing, the 4 is still in the hundreds place, but I am going to notate that as a multiplication of my hundreds place, which is 10 to the second power. Finally, we're going to look at using a number line model to represent decimals. Because my decimal numbers follow the base 10 system, in between my whole values should be 10, 100, 1,000 pieces because it follows that base 10 system. So if I wanted to look at tenths, I would break my whole into 10 equal pieces. So in doing this, I can see each whole is broken up into 10 equal pieces. And if I zoom in just between 0 and 1, I can fill out the tenths that belong in between these whole numbers. Okay, so between 0 and 1, I would be counting by tenths. 0, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths, or 1 whole. All right, now let's zoom in between 1 and 2 and fill in our decimal values. Okay, between 1 and 2, on our number line, we have 1 and 1 tenth, 1 and 2 tenths, 1 and 3 tenths, 1 and 4 tenths, 1 and 5 tenths, 1 and 6 tenths, 1 and 7 tenths, 1 and 8 tenths, 1 and 9 tenths, and then 1 and 10 tenths, or 2 wholes. But what if our number goes to the hundredths place? How can I show that on my number line? Well, for example, if I wanted to plot the number 1 and 43 hundredths, then I need to look to see which values is that going to be in between. I don't want to plot 100 tick marks in between my whole. So what I'm going to do is I'm going to say, well, 1 and 43 hundredths is going to be between 1 and 4 tenths and 1 and 5 tenths. So I'm going to zoom in between those 2 tenths. All right, so now I've zoomed in between 1 and 4 tenths and 1 and 5 tenths. So in order to figure out how many hundredths I need to get to, I'm going to split this into 10 equal pieces as well. All right, so now to determine what these tick marks represent, it can sometimes be easier to go ahead and put a 0 on the end of these decimal numbers. So now that I can see that this is 1 and 40 hundredths and 1 and 50 hundredths, I can think about what values would be in between these amounts. Okay, and so it should look something like this, where the first tick mark after 1 and 4 tenths would be 1 and 41 hundredths, 1 and 42 hundredths, and so on, all the way to 1 and 49 hundredths, and then 1 and 50 hundredths. Okay, so in order to plot 1 and 43 hundredths, I would need to break my number line down or zoom in on my number line so that I can show hundredths. And 1 and 43 hundredths is right here. So in order to think about doing this from my original number line, I'm really zooming in from this value in between this value, right? I'm zooming in so that I can show all of the tick marks that are in between the decimal numbers of 1 and 4 tenths and 1 and 5 tenths. All right, if you have questions, please let me know. Thank you.